Okay, let's look at question number 26. Okay, you are given this series of numbers. As you can see, okay, the first number, okay, you see that 1 times 2 times 4 times 3 times 4 plus 1 is equal to 5 squared, and so on, right? Then in this case, they ask you, in the list of 2017 numbers, can you see that this is 1, 2, and then this part here, this is the 2017 numbers, right? It is actually, can you see that this is 5, 11, 19, and all the way to this number, all the way to this number, whose square are found in this way. How many have the last digit? How many have the last digit equal to 1? Equal to 1. Okay, can you see that now I want to look at this number in this way? I want to look at this number in this way. That means, can I say that I look at 5 squared minus 1? Well, therefore, that would be just equal to what? That would be just equal to 1 times 2 times 3 times 4, right? But can I group it in this way? 1 times 4 multiplied by 2 times 3. Or maybe in this case, you group it this way. And then 11 squared minus 1 can be viewed as what? Can be viewed as 2 times 5, and then multiplied by 3 times 4. Or maybe, well, we group it in this way. Then after that, can you see that when you look at 19 squared minus 1, okay, that will be just equal to what? That will be 3 times 6, and then multiplied by 4 times 5, or 4 times 5. Therefore, in general, if I continue this process, I get m squared minus 1, right? M squared minus 1. And can you see that this part here, okay, what is 1 times 4? Can you see that this one, if you observe carefully, 1 times 4 is the same as 1 times 1 plus 3, right? 1 plus 3, and then multiplied by what? Multiplied by this. This is actually 2 times 3 can be viewed as what? 2 times 3 can be viewed as 1 plus 1 multiplied by 1 plus 2. Therefore, if you observe this pattern, that means in this case, can you continue? Can you continue with this idea? That means in this case, can you see that this part here, this is your 2, right? And then this is 2 times what? 2 times 2 plus 3. Then this part here, okay, let me do some cleaning up. This part is multiplied. Multiplied. Then in this case, this is actually 2 plus 1, which is 3, multiplied by 2 plus 2, or multiplied by 2 plus 2. Therefore, with this idea, we can see that your m squared minus 1 is actually equal to what? Is actually equal to n times n plus 3. Or you group them as one term, right? And then this is just n plus 1 times n plus 2. Understand? Right? Then in this case, obviously, your m squared minus 1 can also factorize, right? Can also be factorized. M minus 1, and then m plus 1, m plus 1. And that is equal to what? That is equal to your n times n plus 3, and then multiplied by n plus 1 multiplied by n plus 2, right? Therefore, in this case, can you see that, because I can do this, right? I can say that m minus 1 is equal to n times n plus 3, right? Then your m plus 1 is actually equal to n plus 1 multiplied by n plus 2. And I think this is correct, because you know why? Because when you do that, can you see that your m minus 1 is actually equal to what? N squared plus 3n, right? And then your m plus 1 here, that would be just what? This would be just n squared plus 3n plus 2. Therefore, in this case, can you see that m would be just equal to 3n squared? N would be just, sorry, I didn't write wrongly. M would be just n squared plus 3n and then plus 1. And then can you see that this part here, that will give you n squared plus 3n plus 1. Therefore, the choices here is actually correct. The choices here is actually correct. Alright. Okay, with that, can you see that? Okay, class, can you see that? Let's look at the original multiplication. Let's look at the original multiplication. When I say original, I'm referring to this one. I'm referring to n minus 1 times n plus 1. Right? Then in this case, can you see that if this n plus 1 is divisible by 10, is divisible by 10. Or you look at this way. If this number is divisible by 10, isn't that your m would give you a last digit? The last digit of n would be 1. Agree, not class? Therefore, in this case, can I say that? Can I say that? Okay, that means can I say that for m to have last digit 1, for m to have last digit 1, right? That means in this case, your n squared plus 3n will have to be in this case, can I say that will have to be divisible by 10. Divisible by 10. I think this is important observation. This would be an important observation. Therefore, it has to be divisible by 10, right? That means, what does it mean? That means in this case, can you see that? Can we also see that n times n plus 3 is always even? I think this part here, if you are not sure, or you think that you want to raise this question, how do you know that it's always even? Can we look at parity? Can we just look at parity? That means in this case, can you see that maybe in this case you can consider n odd, right? If n is odd, then in this case n plus 3 would be even. Therefore, this implies n times n plus 3 is even, right? Okay, therefore, n is even. Obviously, this is even. Therefore, if n is even, this implies n times n plus 3 is even. Therefore, I think this part here, you can do a quick check yourself. Like a very simple one, right? Therefore, now we know that n times n plus 3 is even. What does it mean? Then take note, I want n times n plus 3 to be a multiple of 10, right? Therefore, in this case, one of them. Therefore, can you see that one of them? This implies n or n plus 3 is a multiple of 5. Is a multiple of 5, or divisible by 5 also can, right? Is a multiple of 5. It's a multiple of 5. And in this case, can you see that for n to be a multiple of 5, let's say n to be multiple of 5, then what does it mean? That means it will be 5, 10, 15, and so on, right? And so on. And then can you see that you go all the way? And the last number will be 2015. I think, right? Then if your n plus 3 is a multiple of 5, that means your n is basically what? Your n will be just 2, 7, and then 12, and then you go all the way, right? You go all the way, and you can actually reach 2017. Okay, and in this case, I think you can do a calculation from for 5, 10, 15, all the way to 2015. How many numbers are there? How many numbers are there? I think you can do a quick division. That means in this case, you can do 2015. 2015 divided by 5. Okay, that will give you 403. Therefore, in this case, take note, there are 403 numbers that are multiples of 403. Sorry, 403. There are 403 numbers that are multiple of 5, right? Okay, then can you see that if you look at 2017, right? 2017, okay, this one you will get 404 numbers. 404 numbers. Therefore, in this case, can you see that number of values of n for which the last digit of m is 1 is just equal to what? Therefore, in this case, can I say that what is the total? what is the total that we have? That means in this case the total is actually 403 plus 404. Therefore it is 403 plus 404. And that is just equal to 807. Therefore in this case there are 807 numbers of m. Sorry, let me come back. Okay, sorry, yeah. Okay, let me come back. Yeah. Okay, therefore, let's look at this. Let's look at this. Therefore, there are 807. There are 807 numbers of n. Therefore, in this case, 807. 807 of n, right? 807 of n. It also means 807 of m, right? Therefore, there are 807 numbers such that the last digit is actually ended with 1. Therefore, and hence we solve the question. Yeah. Okay, let me scroll up the solution so that you can see what we are doing. Therefore, this question is not that difficult if you can see the so-called factorization. Yeah. Therefore, let's look at this class. That means in this case, can you see that the first part is the observation. We observe that your m squared is equal to n times n plus 3, and then n plus 1 times n plus 2, right? Okay, then after that, can you see that we deduce that your m is in fact n squared plus 3n plus 1, right? Then after that, take note, for m to have a last digit 1, your n plus 3n will have to be divisible by 10, right? Then we know that n times n plus 3 is always even. Therefore, n or n plus 3 is a multiple of 5. Therefore, in total, we have 807 of them that are multiples of 5, right? And in this case, can you see that the number of m that will give you the last digit 1 is actually 807. With that, I stop here.